Great. And so the two sections we're supposed to cover, I'm not sure I have the sections numbers memorized, but essentially they are graphing. One second, let me close my door. They revolve around this idea of we're graphing. We're going to graph, we call them rational functions. It's a fancy way of just saying we're dealing with fractions. There's probably going to be an x in the denominator somewhere. But it's going to feel pretty similar to when we were graphing polynomial functions. If you remember that section, what we did is we started by talking about first end behavior. What does that look like? How do we determine that? And then we moved into how do we find intercepts, which we already knew how to do. And then we talked about multiplicity. And then once we had all of these pieces, we threw them all together and said, we should be able to draw a graph from this, or at least a very good guess or idea of what the graph should look like. So that's exactly what we're doing here. And that's why this, there are two sections for this, is we like to start with, okay, let's talk about vertical and horizontal asymptotes. And then let's put it all together with, okay, now that we get that, we need to just understand what the zeros are, what their multiplicity is, and sketch a graph. So let's start with the domain of this function. How do I find the domain? We've done this before. Any ideas? I want to find the domain of this function. Remember, when we're doing domain, there's kind of those three different cases we look for. Yes, so I want to set something equal to 0. Specifically, I want to set the denominator equal to 0. I want to avoid that because, well, we're not allowed to divide by 0. The universe kind of explodes when we do that inside of mathematics. So step 1 to determine the domain is set the denominator equal to 0. And then what do I do? So what does this factor to?
Would it be -4 and -2?
Yep. Okay. Now what do I do? Quiet crowd today. Yep, so we set both of those equal to 0 and solve. And so if you're pretty good with kind of solving the factoring equations, you've done a lot of these. Honestly, this next step is sometimes not the most necessary because honestly, if x minus 4 is equal to 0, well, then it's just basic arithmetic. You add 4 to both sides, so x is equal to 4, and x is equal to 2. Now, these are the things that x actually can't be. So x cannot be -4, or sorry, +4, and x cannot be +2. So when I'm writing my domain, well, how do I do that? I want to talk about all of the things that aren't 2 and aren't 4. I'm going to have something like, I'll start it out. I'm going to start with some sort of like a negative infinity. That's going to be part of my answer.
So would it be from like what, negative infinity to 2?
Mm-hmm.
And
Union.
then wouldn't you put the union? And
Mhm.
then after that would go to 4 to, or 2 to 4, yeah, and
Yep.
another union. And then it ends with 4 to infinity.
Yep. Perfect. Okay. And so if we're talking about domain, that is correct. We always just set the bottom equal to 0, go through this process and solve, and we would write it in interval notation. Vertical asymptotes are almost always the exact same thing as domain. So if you are going through the process of solving for a domain, you're essentially going through the exact same process of vertical asymptotes. The only difference is potentially, like right here, I have this x squared minus 6x plus 8. Well, once I factor, I know that's the exact same thing as x minus 4, x minus 2. And so what can happen is maybe these factors could cancel. So potentially this could happen. I could have, if I had like an x minus 2 on top here, then these would cancel out. And I wouldn't consider this guy an asymptote. So that can happen, but in general, for the most part, what our vertical asymptotes are going to be, they're these guys. So when solving for vertical asymptotes, we do the exact same thing as when we're solving for our domain. And instead of, well, writing this weird and funky domain thing, it's actually a lot nicer. Our vertical asymptotes are, we just take these. They're whatever your x cannot be. Sometimes people try and be cute and write it like this. If you want to write it like this and say that's your asymptotes, it's kind of true. I mean, your graph will not be able to equal these values, but really your asymptotes are the equation themselves. So this is how I write my vertical asymptotes. X is equal to 4 and x is equal to 2, or you can write it as two separate equations. Either one is fine. Any questions about how I got domain, how I got vertical asymptotes?
Well, you said it's what it can't equal is what the definition is. Okay.
Yeah. Yep. So when you're going through solving for your domain, you go through this process. You factor, you say what can't x be, and these are actually your vertical asymptotes, assuming nothing, like we don't have weird factors canceling. But in this case, nothing cancels, so these are actually my vertical asymptotes. So all I did was take these guys, move them down here, and then cross them out. Say they can't be 4, can't be 2. Everyone good up to there. Okay, so something that we do like to talk about with vertical asymptotes that we don't really care about with domain is we actually do worry about the multiplicity. We've seen multiplicities before. We've seen them more associated with zeros as opposed to anything in the domain, but the process is exactly the same. I look at the factored form, and then I look at the power, and that's going to tell me the multiplicity. If this is x squared here, or x minus 4 squared, well, that's going to have a multiplicity of 2. If it's x to the third, that's going to have a multiplicity of 3, so on and so forth. So what is the multiplicity associated with each of my vertical asymptotes?
Is it just 1 and 1?
Yep. And we'll talk about more what that actually means when we go through and graphing, but it is important. When we find zeros, we find their multiplicities. When we find vertical asymptotes, we find their multiplicities. Great. So I found my domain, I found my vertical asymptotes. It wasn't really asking for the multiplicity, but I'm going to write it. It's important. How do I find my horizontal asymptotes? And you can answer that in general, or you can answer that in this case. I'm going to actually go back to what the original form was because it helps us kind of see my vertical asymptotes or my horizontal asymptote is. Probably have needed to watch the video to answer this question. Okay, does anyone know the cases of what can happen with a horizontal asymptote? Well, I do. So there are three cases. I mentioned them in the video. I'll probably bring them up when we actually get into the next example of graphing. But there are three cases. One of them is in all these cases, actually, we look at the degree. So I look at the degree of the top. I look at the degree of the bottom. So in this case, my degree on top is 2. My degree on bottom is 2. So this is the case when the degrees are the same. The other cases are the degree on the bottom is bigger than the top. And the last one is the degree on top is bigger than the degree on the bottom. So in each case, there is a process on how to find the horizontal asymptote. In this case, when both degrees are equal, what I do is I look at the coefficients of each of these, the leading coefficients of both polynomials on the top and the bottom. So here I have x squared. My leading coefficient is 2. On the bottom, I have x squared. My leading coefficient, even though it's not really there, is that invisible 1. So then when I talk about my horizontal asymptote, it's in this case, it's a y, it's horizontal, so it's going to be a y is equal to leading coefficient on top is 2, leading coefficient on the bottom is 1, so it's just y is equal to 2. You can write it as 2 over 1 if you really want to. It's kind of weird to leave it as that fraction, so I recommend just doing the y is equal to 2. Honestly, like I would write this as my final answer and box it. So that's my horizontal asymptote. So not to kind of dangle this concept out there and say, oh, trust me, this is important information. What are horizontal and vertical asymptotes? Well, when I get to my graphing, my horizontal asymptotes or my vertical asymptotes are going to say, okay, when I'm drawing my graph, my x can't be those values. So I'm going to be drawing, let's see, horizontal asymptotes to kind of guide where my graph is going to do. And then same thing with horizontal. Horizontal, y is equal to 2. That's going to very much determine what my graph is going to look like. And then I'll use this information when we get to the next slide to kind of connect the dots and say, okay, here's what's going to happen here, and maybe something's going to happen here. And all of this information is determined by what we just talked about, and then zeros, which we already know. We've seen those before. So let you practice these concepts, make sure that you understand what vertical and horizontal asymptotes are, how to find the multiplicities. Yes, you don't know how to apply them, but you will know how to apply them in, I don't know, 20 minutes or so. So any questions about these guys? Cool. So instead of going to the module for this week for starters, since we are a day behind, start by going to last week's module. So let me pause it and make sure I'm not pulling up anything weird. So we are on the 11th. So on the 10th, or the week of or module 10, 5.5 is the thing you should start with. It's just, I think, 4 questions that are, I can just pull it up. I don't know, I'm guessing. I don't know, never mind. There we go. Yeah, it's just 5 questions that have you finding domain, finding vertical and horizontal asymptotes. Really, if you want to skip this part, it's good practice, but we've done all of this before. And I'm not super concerned about you guys being able to find domain. I want to make sure that you understand how to find vertical and horizontal asymptotes so that we're able to kind of piece everything together. Okay, let me stop my recording. I'm going to pause my recording, and actually I'm going to draw, so turn off my camera. Okay. And so, well, we actually already found the horizontal asymptote and vertical asymptote for this, guys. But for a quick reminder, find my vertical asymptote, set this equal to 0, solve. So I got x was -4, x minus 2 is equal to 0. Notice how neither of these are going to cancel anything in the denominator. So that's not something I'm super concerned about. And so what I do from here is I set those equal to 0. If this was domain, I would say x can't be 4, x can't be 2. Since we are dealing with vertical asymptotes, we actually say the opposite. We say x has to be these things. These are going to be vertical lines that, well, overall, my graph won't actually be equal to ever. Those are technically equations. We also talked about multiplicity. I just look at the powers of each of these factors. 1, 1. So 1 and 1. What was my horizontal asymptote, or how do I find that, since we just talked about that?
The coefficient, the leading coefficient of the top one and the bottom one?
Yep, degrees are the same, so that's a case 2. So what is my horizontal asymptote here?
2.
Okay. So what we didn't talk about is our zeros. That is valuable. We want to talk about my zeros. I want to talk about their multiplicities. So when I am doing vertical asymptotes, I set my bottom equal to 0 and solve, right? I set these equal to 0, found my x and my y. Anyone have an idea, or maybe someone has watched the video, about how I might find my zeros for these fractions, or my x-intercepts? You can also throw out a random guess, because looking at the process, it's very similar to how we found vertical asymptotes. So if you're thinking of it might be this, it's probably that. So guesses are fine here.
So will the zeros be like 4 and 2?
Those are my vertical asymptotes. So those are going to be the same thing as my zeros. I like the guess. I like the effort. Any other ideas? Wait for one more guess. Yeah, go ahead.
The numerator
Yes, perfect.
equal to 0.
Mm-hmm. Right. It makes sense, right? Kind of logically. Well, I said the bottom equal to 0 and solve. What left do I have? I could set the top equal to 0 and solve. So in this case, 2x is equal to 0. I divide both sides by 2. And so I take the square root of both sides. X is 0. So one of my zeros is 0. What is the multiplicity of that 0?
2.
2. What does that mean? A bounce, a wiggle, or a cross?
Bounce.
Bounce. Great. Y-intercept. How do I find it? Oh, I had a thought. Backed out.
Would you say x is 0 or something?
Yep. So to find my y-intercept, I plug in 0 for x everywhere. So 2 times 0 squared over 0 squared minus 6 times 0. 8. Sometimes we have to do a little bit of arithmetic. In this case, it's actually pretty easy, right? 2 times 0 squared is 0. On the bottom, we have 0 minus 0 plus 8. So it's just 0. Everyone good with the pieces? Maybe not the why do we need all of this and how are we going to put it all together, but at least how we got those things. Cool. Take that. So let's give myself some space to draw. Okay. Now I'm going to put everything together. Well, let's start with the things I know. Let's plot my intercepts. That's something that's not super new. And in this case is actually pretty easy to do, right? My zeros are 0, so that's this. And my y-intercept is also that. So actually, that's all I have to do for my intercepts. Remember that when I'm doing my graph and I'm drawing my things, the multiplicity of that intercept is going to be a bounce, but that's honestly about it for that part of the question. Now, let's plot my asymptotes. My horizontal asymptote is y is equal to 2. Well, it's horizontal, so if you're wondering, is that going to be up and down or left and right? Well, horizontal means left and right, so that is my horizontal asymptote. My vertical asymptotes are 2 and 4. Maybe I'll extend this a little. And well, surprise, surprise, they're vertical. So I should be drawing vertical lines. Everything good so far. All I did was put my intercepts and I plot my asymptotes, those dashed lines. So these, I plotted that, I plotted that. Everyone good so far?
So they're dashed lines and not solid?
Yes, because technically these are kind of guides. They're not actually my graph. I'm going to use them to say, okay, where does my graph go? Is it going to go up? Is it going to go down? But they are dashed lines because they're not technically part of my graph. Good question. So just to make that clear, let's make my graph this rather good color. Yeah, that's fine. That. And so it is going to be a solid line. So now we asked ourselves, we went through all of this trouble of finding my horizontal vertical asymptotes. My horizontal asymptotes always determine my end behavior. So when I was drawing my graphs of polynomial functions, that would be my starting point. I would always start on the left side of my graph, say it's either all the way up or all the way down. And on the right side of my graph, it's all the way up or all the way down. In this case, it's just telling me that my graph is going to start over here and it's going to end over here. So with that in mind, I'm going to start drawing my graph. It's going to start here. It's going to go on forever and ever. And now my first question is, well, what do I do? You connect the dots, just like we did with the polynomial graphs. We say, okay, I start there. I go to my very first dot. Or my asymptote, it might be an asymptote, might be a vertical asymptote. I go to that dot. What is the multiplicity of that dot? What do I do at that intercept?
Should bounce.
It's a bounce, right? That's right here. So I'm going to bounce off of it, bounce. And now I come to this vertical asymptote. I can't ever cross a vertical asymptote. So what's going to happen is I'm going to try my best to cross it. I'm going to get really close to it. And then I'm going to say, oh, well, I can either go something like this, or I can go something like that. Well, let's think about the two options. I don't have any more intercepts, right? So my graph couldn't do this because, well, that would imply there is some sort of intercept here, which is not the case. So I actually can't go in that direction. So instead, I'm going to go up forever and ever and ever. And then eventually I have to concede and say, well, I'm not going to ever be able to cross that vertical asymptote. So I have to pick up my pencil. My pencil is picked up. Everyone good with the left side? Cool. So I do that. And now the question becomes, what do I do at my vertical asymptotes? So for vertical asymptotes, when you will see this in the video, if my multiplicity is odd, that means I go on opposite sides of the asymptote. If the multiplicity is even, I go on the same side. What does that mean here? So I went through my first step, the left side of my graph. I started over here. I went down, bounced off the intercept, went to my vertical asymptote. I was forced to go up. Now, once I pick up my pencil, I ask myself, what do I do now? Like, where do I'm either going to put my pencil here and continue drawing, or I'm going to put my pencil down here and continue drawing. And so what determines that is, well, the multiplicity of my asymptotes. So I picked up my pencil here. I look at 2. My multiplicity is 1, which is odd. So I'm going to go on the opposite side of wherever I picked up my pencil. So I picked up my pencil up top. I pick it up, and it's an opposite, so I set it down here. Then I continue drawing. And now I say, okay, well, is there some sort of intercept I can connect to? Is there something I can cross? Is there something I can bounce? Is there something I can wiggle through? No. And so I actually, like Austin brought up in the chat, that it's a good idea to kind of treat these things as barriers. So I try and say, okay, I'm going to go up here and maybe I'll be able to cross it. Oh, I can't actually do that because I don't have an intercept. So it's almost like I'm blocked off in that direction. So I start to go in that direction, then, oh, I can't go any further. I have to turn back around. Almost like driving the car. You try and go some sort of direction and you're either going to be turned around or maybe you'll be able to cross it. And then I pick up my pen or pencil, whatever. So with this information, anyone want to help me close out this example? What do I do? Claim that I've done enough of the process and the opposite and the same side or whatever. So how do I?
You go to the opposite side again.
Yep. So pick up my pencil, I go to the opposite side, and then what am I going to do? So I'm going to start drawing, and then what happens?
Say above the horizontal asymptote.
Yeah, right. The horizontal asymptote is my end behavior. So I say, okay, well, it's going to go really close to that forever and ever, and I'm done. So it's almost like you're trying to be a detective. You're going to try and solve mysteries. You're filling in the blanks. I have a blank on the left side of my graph. What do I do? Well, okay, let's see. My intercepts, am I bouncing? Am I wiggling? Do I do opposite sides? Okay, now I've filled out that region. What about here? Oh, okay, I see it's going to be on the opposite side. It has no intercepts. Okay, I'm done with that region. And then close out in this region. It's almost like reading a book is how I suggest going through and making sure you're almost filling out each of these, I don't know, pages. And so one last thing before I let you loose to practice this, you might be wondering, what does a same side look like? So let's say that my asymptote here, x is equal to 4, was a same side. So if that's the case, when I get to this point of picking up my pencil here, right here, it's on the same side. So instead of going to the opposite, going from down to up, I would go like this. That is what a same side would look like. So that's what I mean when I'm saying same versus opposite, something to be aware of. Obviously, that's not what my actual graph looks like, but that is what a same side looks like. And if you were to throw this into Desmos or a graphing calculator, kind of cycling back to Courtney's question, it wouldn't have these intercepts. So you wouldn't really see them, or not, sorry, asymptotes. You wouldn't see, why is it not letting me erase? You wouldn't see any of these dotted lines that I drew in. It would just look almost like that. So if you're kind of practicing and saying, oh, I want to check to make sure my answer is correct. Oops, a little too far. and you graph on Desmos, that's what it looks like. But the asymptotes are there to guide you so that you know when you're drawing of where do I start, where do I stop, when do I flip, and stuff like that. So that's just, the graph itself is the graph in brown. The black stuff was there just to help us. Any questions? I am aware this is a lot. This is arguably the most complicated thing we will do this semester. So make sure when you're practicing this, you're talking to your group mates. What's probably going to happen is someone says, I feel good about vertical asymptotes, but nothing else makes sense. Someone else might say, I feel good about zeros and multiplicities because we've seen this before. Nothing else makes sense. We'll talk to each other and see if you can kind of piece together all of the things and get a final graph. So that is, I wouldn't go back and do any more of the worksheet that we started with today. I would go back into the modules and go to, go to this week's. And practice these. And so if you are able to get one of these done, great. If you're able to get two of these done, great. Like, that's a win today. This is hard. This is difficult. If you're able to do more, awesome. We didn't actually cover this. That's fine. If you're able to do more, that's awesome. But that should be your goal, is I'm going to make sure that I get this one lockdown. Can I find all of these pieces of information? Can I graph? If you complete two, you can call it a day and go ahead and head out, even if it's early from class. But try and get at least one in your group. Make sure that you're talking to each other, and then submit whatever you get from 5.5 for your in-class assignment today. Are there any questions outside of content today? Like I said, we don't get to this today. That's fine. If it is super important or shows up on the exam, maybe I'll go through an example before the exam. Honestly, for today, this is more than enough, making sure you can do all of these pieces of information. So yeah, so I give you a longer pause. Are there any questions before I put you in your breakout rooms? Cool.